Hey everyone, welcome back to my channel, and today we are going to talk about what is a distributed system. So distributed system is a word that sounds very haunting at first, but once you try to break it down, it's really simple, right? So I don't want to start with a textbook definition, but I don't want to start with a definition at all. So I will start with an example, right? Let's assume we are building a simple to-do application, and it is used by thousands of users, right? Or maybe initially we just have a couple of users which are our friends and maybe someone from our family. Okay, so now when you start, right, maybe you are storing everything in memory in on your front end, right? And which is a very bad design, of course, but let's assume we are starting there. Okay, so that's a terrible design choice, and the data is lost once someone clears the browser history. But it's a simple application, it lives within your browser, and there is no network partition, right? There is no network calls between components of your system. Your system basically has no component, it only has a front end, and storage is the user's storage, right? And maybe that works for a few applications, but in real world, like, most applications are CRUD application, but they have a lot of added business complexity, the scale complexity, and different constraints, and some weird use cases which are not natural to write but still are expected from our application. So in those scenarios we introduce a distributed system. Now one thing, I would like to make it clear, right? Distributed system does not mean microservices architecture, right? In most scenarios it is microservices, but it doesn't have to be, right? You have a single backend. So let's expand on our example, right? We still have a to do application, but now we want to introduce a dedicated backend, right? Irrelevant to our discussion as of now, but let's assume, for the sake of discussion, it's spring boot and java, right? And it is hosted on, let's say, ec2 aws. It could be hosted anywhere, again that is not the important part. And it connects to a database, let's say it's a postgres rds instance on aws again. And let's assume we have some common queries, right? Because let's assume there are certain tasks which are completed in the past and can't be edited. Those are easily cacheable, right? Because if they are not changing, they like that kind of data is best suited for caching. So maybe you are using a managed cache again by redis. Maybe there is some instances, or sometimes maybe during late night or early mornings, where users are using your applications a lot more than usual, so you have bursty traffic as well. So to absorb that, right, a spike in request, you have a queue. So you are using kafka. Okay, and let's assume you are using amazon msk, which is just a simple managed service by amazon, right? There is a lot of complexity if you are going to manage your own kafka. For now, let's assume we are using amazon msk. And there would be even more components to a backend system, but these are like very common components, right? In most applications you will find this. At the very least, you will have a backend and you will have a rds or your database. Okay, considering just these two, right, you still have a distributed system. Why? Because your application lives in one compute node, right? Which is, let's think of it like a completely separate computer. And your rds, it also lives on a different node. And more importantly, there is a network call, right? Whenever you are writing your application, you connect to the database, and whenever you are making a query, right, you hit the database runs the query, and it returns the result. And you are there is some network delay, you don't instantly get the results. No matter how efficient your query is, there is still some network delay, right? There is still some network communication, there is some communication over a network. It's not in the same system. And the same thing goes for the cache, right? The cache is very fast, right? It's in memory, but still it takes milliseconds. It's again, milliseconds is very acceptable for most applications, but it lives on a separate node, right? That's why there is a network call, which is still expensive, and at scale it breaks, right? It breaks in the sense that you need other infrastructure, there are other consideration. I will not get into it in this specific video, but at scale the distributed system becomes very complex, but we also require it, because what happens if your application is down, I mean your cache is down, you don't want your entire application to be down, right? If it was a single like compute instance, maybe that goes down, and it had your cache, it had your database, it had your backend. Now everything will not work, everything will stop working. So fault isolation is a very important feature, and also the scalability, right? Your database may have a different need for processors, your backend application may be very simple, and maybe it does not need a lot of compute resources, and same thing for your cache. So each component can have different requirements, so it also helps us with cost isolation, but at the same time fault isolation, that's the most important aspect in my opinion in most applications, right? Obviously there are certain aspects which are very important, like if your backend goes down, it doesn't matter if your database is up, it doesn't matter if your cache is working, it doesn't matter if your queue is working, right? But if your queue is down, right, if Kafka is not working, your application can still function, right? Most of your features will still work, more or less. And there are various like techniques to mitigate those issues, right? And even the managed services are very reliable, like maybe 99.99% uptime or something in that realm. Okay, so that is not the biggest concern, and obviously there are ways to mitigate them. But the point is, now we are making a separate network call for each and every operation. Like we are talking to the queue, there's a network call. We are talking with the cache, there's a network call. We are communicating with the RDS, there's a network call. So it's not a bad thing. I know it sounds very bad, it sounds very slow, but it's not very inefficient. Most applications work just fine with this infrastructure, but you need to understand that there is a network call, right? There is something. So when your application scales, right, it makes a big difference. Obviously when I say scale, like someone may have 100 daily active users, someone may have 1,000, and someone may have 10,000, and if you are Facebook, you have millions or billions of users using your application every day. So at each level, the level of complexity, the level of infrastructure and level of consideration you need to make are very different, right? You don't want to do engineering like you have a million users if you just have 100 users, or if you are just building an admin panel. So it makes a whole lot of difference. But more or less that's a distributed system in a nutshell, right? Again, you will come across microservices, you will come across various techniques and theory to how to handle those systems, right? And those are important, definitely, but those are like advanced concepts, and microservices are not necessary for a distributed system. That's what I want to convey here, right? I hope you have a better idea of what a distributed system means. If you have any specific questions, please do let me know in the comments. Don't forget to subscribe, and I will see you guys in the next video. Thank you.